So we're going to start out this little video with a review of scientific notation. So if you have a number like that and you want to write it in scientific notation, you're going to move the decimal, or basically divide. Here's a decimal at the end of the last zero. You're going to divide this by 110, right? Because that shifts at one place. 2, 3, 4, 5, 6 tens. So you're going to have 1.25 times 10. I'm going to put an equation here. Times 10 raised to the 6th power. So that's the scientific notation. 1, just the ones place, then the decimal net. So that number here is the same as that number here. Your calculator is going to probably look at it like this. E means times 10 raised to, plus 6 means 6th power. Negative 6 would be the other way. So let's look at this as a regular number. This is just times 10 to the third, so I'm just going to move it 3 decimal places. That's it. That's the number. Over here, your calculator's going to view it, or you'll see it, or Excel. Like that. So this last example in scientific notation is going to be, this one you have to multiply it to get to the 1. So I'm going to have to divide it to make it equal here. So I'm going to go 1, 2, 3, 4 tens. And I'll just make that an equation. Hopefully you're following along here. How many did I move it? 1, 2, 3, 4. So that means to get back to this number from here to here, I would divide it by 4 tens. I move the decimal 4 places this way. So this number and this number are the same. The calculator Excel will express it this way. Okay, so you'll have more review on that. Hopefully you got that. Okay, so this is a table that shows you the amount of people in the United States by age category. And these are different projections. So we're about here now. So this is the projection. Well, this is this year, and then in 10 years, this is what they're expecting, and etc. Notice it says the number is in thousands. So that means that there is not 334,503 people in the United States. You'd have to multiply that by 1,000, which is the same thing as adding 3 zeros. There's 334 million. They don't want to put all those zeros in here, so that they do it that way. So in 2020, there's expected to be 20,568,000 children under 5. So that would be right here. The actual number then is times 10 to the third, because 1,000 is times 10 to the third, right? 3, 6, 9, 12. So you just add 3 zeros on. And that's how many actual children there are, 20,568,000 under the age of 5. So we're still doing unit rates here. So using the given table, how many people 18 to 64 and over 65 and over are there. So we want to know how many people in this age group and how many people in this age group in 2015. And then I want to compute the rate of, there's the numerator, people 18 to 64 per person, per one person age 65. And then I'll give an explanation of the answer. So if you go back up to the table, there's that many people, which is actually that many people between those ages, and that many or that many over 65. So you really can just cancel. They're both thousands, so they cancel. This is the number of people 18 to 64. This is the number of people 65 and over. Now, I don't need to set up a proportion because I'm doing per one. I'm just going to divide these two numbers, and you get that. Now, I'm going to interpret this for you because this is just this divided by this. So you get 4.18 over 1. So in 2015, there were 4.18 people between 18 and 64 for every person, or one person age 65 plus. Another way of looking at it was in 2015, there's about 4 times as many people 18 to 64 as there were people 65 plus. So it's a good way to look at that. That's how real data is. So I'm going to use a table up above and how many people under 18 and 65 and over were there in 2015. And then compute the ratio of children under 18 per person 65 and over. And I'm going to provide a written explanation of the answer. So this should be pretty clear here. So I'm going to put this number in here. You can pause it. Put this number in here. And then I'm going to put down how you're going to compute it. You should think about that. You should pause it and figure out how I'm going to compute this. So there is the answer. Notice I didn't put the denominator in. Hopefully you know there's a denominator there, which is 1. So there's about 1.5 times as many. That's why I'll leave that one for you actually. So it's 73,635 divided by that, I get that. So these two ratios are the same. Now how can you interpret that? What does this mean? I'd pause it and I'm going to put the answer in, but you should pause it and think about what does that mean. So there is what it means. You can always pause this. So I'm going to do one more of these. This one is a little more complicated because it's going to involve something a little different. So the U.S. total debt reached 21.9 trillion in 2018. Assuming there are about 329 million people living in the United States, what is the per capita? That means per one. That means each person's share of the United States debt. It should be that, right? Thank you, Susan. Calculate and then provide a written answer, a written meaning for your answer. So it's a ratio. Now, importantly, you want to know share of debt per person. So I'm going to do this debt divided by people. How many dollars per person? So you might want to pause it and write it out and see what you can get. It's a little tricky here because you're dealing with millions and trillions. So notice this is dollars per person. And I took the trillions, which is 10 to the 12th power, thousands, millions, billions, trillions, 3, 6, 9, 12. And I changed this to this. So I'm really dividing this. Now, if you remember from high school, these exponents, basically this means you have 12 zeros, and this means you have 6 zeros. So you can cancel, because each zero is multiplied by 10, so you're really canceling tens. So you really wind up with this, which we'll get in a minute. But just to explain how I got from here to here a little better, the top number here I'm going to move this to make it a regular number. That's 21 point, well, I'm not going to move the point. I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and I'll make it bigger. And down here I got 329, 1, 2, 3, 4, 5, 6, because that's millions. Blow it up. And really what I'm doing is canceling zeros. Cancel one out here. Blow that up. Cancel another out here. Etc. So if I cancel out, I'm going to be able to cancel out 3, 4, 5, 6 zeros on the bottom. So if I cancel out 6 zeros on the top, I'm going to have 6 left. That's why I have that. And so the final answer. So I changed this into what you would put into your calculator. 21.9 times 10 to the 6 divided by 329. If you're not careful, if you don't use parentheses, it's going to take the 10 to the 6th power divided by 329, and then this might not work. So very careful about the order of operations. This one probably would. But, so that's what I get. Now here's the thing. I mean, all right, we did all this. You got an answer. What does it mean? All right, so I'm going to pause. I'm going to just slap down here what it means. You might want to pause it and think about what does it mean. So there it is. The debt per person is $66,565.35, and that was a while ago. So that's what that means. If we divided the total debt of the country by every person in the country, each person would owe that much money.